Okay, I think we'll get started on the next event in our IEEE Electric Vehicle Conference. This is going to be a series of talks by some world-class experts in electric vehicle technology. And we're going to start with Dr. Julian Weber. Julian is currently head of Innovation Projects e-Mobility within Project I, BMW Group's EV think tank and product line. Among his responsibilities is the management of the worldwide Mini E and BMW active fleet operations. He began working for the BMW Group in 1997 after graduating in mechanical engineering with a major in design and development at the Technical University of Munich, Germany. And he received a doctorate at Karlsruhe University in Germany. As a member of the BMW team, Dr. Weber has worked in process consulting, experimental vehicle build, as manager of purchasing strategy and innovation management North America, located in Spartanburg, South Carolina, and in different management positions in the development division for electronics and driver environment, and as a strategy manager for product strategy e-mobility. He is an adjunct associate professor at Clemson University, CUI-CAR, in Greenville, South Carolina, where he lectures in graduate courses in automotive development, and he's published numerous papers as well as the book, Automotive Development Processes. Dr. Weber.
Thank you very much. Good morning, everyone. I'm always glad coming. I'm not reading my CV again. Okay. I'm always glad coming back to South Carolina. As you have heard, this is kind of my second home, and the two hats I'm wearing as an adjunct professor here for Clemson ICAR and as a manager with BMW. So today, the focus, of course, is more on what I do at BMW. And thank you for giving me the opportunity to sharing with you all what BMW is doing in terms of e-mobility. So let's see, it works. We have heard this morning about the strategic framework that drives e-mobility, about environmental issues, urbanization, and also politics that ask for alternative mobility solutions. There's one thing missing, and that is the customer. I mean, BMW probably would bring, how should I say, a legal requirement fulfiller as a car or something unemotional like that, or a funding receiver. We would like to answer this challenge with a car where people get out and don't say, oh, this was pretty good for the environment, but on the other hand, pretty boring. We want to have people getting out of these cars with a huge smile on their face and saying, this is how I expect a company like BMW to interpret modern times mobility. So out of this strategic framework, BMW started in 2008 thinking about how could the car of the future look like. And BMW is not a big surprise, engineering-driven company. Engineers, are simply structured, and so we said, if we bring something as radical, new, as an EV to the market, we should rather test this first. We should rather test not only technology, but also user behavior, charging, functionality of the car. Think about the creeping mode everyone in the United States expects from an automatic car. With an EV, do you still expect creeping mode if you can operate the car more or less with one pedal? All these things you really have to test first before you can, with a good conscience in our perception, hand over such car to customers. So this is how we thought would be a good approach. We brought first a fleet of Mini E's, electrified Minis where, I mean, they are great to drive, but we would never sell this car on the market. Why? By converting the normal Mini to an electric car, we lost the complete trunk, the rear seat bench. This is nothing you would sell someone. But we were able, as early as 2010, giving these cars internationally to users and see how they would drive electrically. And the second stage, like the second test loop of the whole thing, is the BMW Active E. That is again a conversion of a BMW 1 Series Coupe. And it already includes some of the latest series components, like the battery cells and battery modules we intend to use later on, or the electric motor, but it's still a conversion. The Mini E actually was built with 5,200 laptop cells. I don't think that anyone would intend to have this solution for an EV as a series solution later on. So the two cars, and you can both see them below in the exhibition, the Mini E and the Active E, in our perception, are test cycles for the introduction of a series product that will be the i3. And also, volume, therefore, is relatively limited. Mini E's were around 650 worldwide, and BMW Active E will be around 1,200 worldwide. Good. Let's talk about the Mini E for a second. And the Mini E project right now is actually more or less at the end. And we have been able to collect over 15 million miles in an international base so far. Let's see, is this working? I don't know why the clicker. Is it possible you would click to the next page? The clicker doesn't work. Okay, thank you. So what you see here, these are the different markets where we tested the Mini E fleets, always with local government included, scientific monitoring, and infrastructure and energy partners. Because it is important, and there is a huge difference how these cars are used in the US or in China. My favorite example that has nothing to do with e-mobility, but user behavior. What is the percentage of pickup trucks in passenger and light truck volume in the US? Probably something about 30%. What it is in Germany? 0. There are no pickup trucks in Germany. So user behavior is relatively different from state to state. Therefore, we need to really watch how users, what do they like when driving electrically, and what do they dislike. I'm only going to show you one result out of this Mini E trial, and this curve shows what is the cumulated average daily driven distance. And this is a comparison among electrified Minis and combustion engine driven Minis, and also a BMW 1. And the first thing you see is there is more or less no difference in how people drive with EVs or combustion engine-driven cars. And the second thing is 95% of these people drive less than 60 kilometers a day with their car. So range was not the big problem at the end of the Mini E field trial. That's a very important fact here. Good. Going back from the Mini E to the Active E, as I said, here we did some improvements. We have proper battery cells. What you can see here is the battery is located everywhere in the car where things are not further needed. So parts of the battery are where the combustion engine was, a part of the battery is where the shaft was, and another part of the battery is where the fuel tank was. But still, it is a conversion with all the associated disadvantages, like weight distribution and so on. We are just about to start the fleet tests with the Active E, and last month the first cars had been handed over here in the US. So this is Mr. Maloney, one of our pioneers from the Mini E program, proudly showing his number plate here. Why I show you that, I know it's a little bit cheeky, but it shows, very importantly, that these guys, and that reflects the opinion of a couple of people, not only in the US, also in China, saving the environment is one part of the motivation for electric vehicles. Getting independent from imports like oil or being able to use oil for different purposes is another very important driver for e-mobility here. Good, but as I said, it's a conversion of an existing thing, and conversions always mean compromise. This room here is a conference hall, a ballroom. We could convert it into an apartment building, but you will probably agree that there would be some compromises, maybe with respect to daylight and things like that. So at the end of the day, if you want to offer an EV that really appeals to the customer, that is a real BMW, you have to start with a vehicle structure that is based on being an electric vehicle. We call it a purpose design. So very simple, looks a little bit like cars 100 years ago. We have what we call a drive module that includes the battery, a flat battery, and the e-motor and all the axles. And on top of that, we have a carbon fiber life cell, which is the body. At the end of the day, that's the way we built cars, as I said, 80 years ago and so on. But with a lot of advantages like weight reduction through lightweight materials, the rear-wheel drive, typically BMW for optimum traction, crash safety, not only for occupants but also for the battery, and we can, in production, build the cars in 2 separated product lines. Good. I'm just showing you a couple of pictures how the whole thing would look like. That's the carbon fiber cell with the aluminum space frame for this energy storage. The red thing here is the battery, flat located in the frame. This is a section through the car where you can see you even get a very even interior floor with the battery. And yeah, oops. So what is the benefit of all that? The benefit of the purpose design, together with lightweight and aerodynamics and so on, is that we get 33% roughly more range out of the same size battery than with comparable normal conversion EVs. That's the big advantage we have from lightweight and from this architecture. Good, and as we showed at the Geneva Auto Show and at the IAA, so this is how we think the car should look like. That's our megacity vehicle, the i3, that will come late in 2013. And you can see also from the interior, it's not only an EV, it's a completely different car. And for those who think this EV is too small for them, we also offer a more sportive solution, the i8, which is a sports car which has the acceleration of a BMW M3 and the consumption of a fuel consumption of a 118 diesel. And so we think as a plug-in hybrid, this is also a solution that shows that being sustainable must not include boredom. Good, so these are the cars. But being sustainable and offering sustainable solutions for the future, in my perception, also has to include different things like services. We have people who use cars but also use bicycles, have to go on public transport and so on. A parking lot in downtown London is about 900 euros a month, so even people who can afford these cars would probably think about taking the subway for the last mile. So what do we offer here? We think there must be 3 different services in addition to the cars. Car-dependent mobility services, the car knows where the next charging station is. Car-related mobility services that can be used by any car driver, like car-sharing schemes, and also car-independent mobility services, like offering information about the city you are going to visit with your car. And all that is included in BMW i. Am I? Okay, very good. So BMW i, and this is another important message here. We won't only sell electrified vehicles within the next couple of years. There is still the brand BMW, there's still the brand BMW M, and like BMW M is for the performance cars, BMW i will be the brand for products and services that are very visionary in terms of mobility and also in design. Good. I'm jumping over a couple of slides here. Just as a summary, so what is new? The concept of the vehicle is completely new. It's not only the drivetrain. We have absolutely new materials in here, recycled materials that are sustainable. We have a new production concept. For example, 100% renewable energy for the production of the i3, or only secondary aluminum to reduce CO2 emissions. We have the new electric drivetrain. The battery and the motor are BMW core products. We also brought new processes for BMW internally and for our employees. The design is inspiring and pioneering, so it's a brand new product for the future of individual mobility. And of course, we want to attract new customers with that, because the 3rd pillar of sustainability is economic sustainability, and we are convinced that we make a lot of profit with these cars. Thank you very much. Have a good conference.
Thank you, Julian. Before we go to the next speaker, I do want to make a quick comment. I live in Torrance, California. City of Torrance has made a partnership with Honda and Google and Stanford University to collect data on charging of Honda electric vehicles. So this is something that's happening even in relatively small cities. Torrance is only 130,000 people. The next speaker will be Jay Iyengar, who is the Global Director and Head of Electrified Propulsion Systems in Chrysler Group, LLC. She has over 22 years of professional experience in the auto industry, with experience in powertrain components and systems development, embedded control and calibration, diagnostics and torque security, quality engineering processes, and program management. She has experience in working with global engineering organizations in multi-company environments to develop and commercialize complex technologies and systems. Her current responsibilities include leading global engineering of electrified powertrains and systems for Chrysler Group, LLC. She's also responsible for strategic technology roadmap and innovation, in addition to delivering electrified powertrains to the vehicle platforms by managing all aspects of product development, cost, and quality. Chrysler Group is the lead for electrified powertrain development for Chrysler and Fiat. She has a BS in Mechanical Engineering from Mysore University in India, an MS in Mechanical Engineering at the Indian Institute of Technology from Bombay, India, and an MS in Mechanical Engineering at Wayne State University. Jay is a member of IEEE and an active volunteer at the Power Electronics Society, which is one of our sponsoring societies, and she's working with Lee Stogner and I to do a roadmap for electric vehicles for the IEEE. Jay?
Thank you. Good morning. I agree with Pat. It was too long of an introduction. We got to cut that down. So I have the privilege of leading electrification technology development for Chrysler and Fiat. And normally when I call into these conferences, I jump into the technology, the cost, technical developments, roadmap, that type of discussions. But today I thought I'd take a different approach. I want to talk about, give you a flavor of the complexity involved in electrification, especially when you're an OEM trying to introduce these technologies, and get a little bit more into the people that are involved and how diverse this is before I get into adoption of electric vehicles per se. That's the theme of my presentation, but I want to start from general first and get into the specifics of electric vehicles as later. So if I can find the clicker, that would be great. Okay. Okay, I'm going to quickly start off with, I think you heard these from this morning from many speakers, but what are the main drivers? Why do we need to do this? 4 simple reasons. It's the environment, it's sustainability. Sustainability, I define it as capacity to endure, whether you are a company or whether you are an enterprise or whether you are the planet, capacity to endure. Then you have the regulations, and then you obviously have the customer, and there's a lot more details about competition. We look at a lot of these things. All of these thought processes go into a hopper, and we come back with part of our decision-making process is, yes, there is a change ahead, and we all acknowledge that. Before I get into the details, I want to give you a quick terminology introduction here, talk about, the term electrification is not just EVs as far as we are concerned. To us, it is a whole variety of technologies, starting all the way from, as you go down that graph there, the degree of electrification increases, so your dependency on the ICE engine decreases. So you start all the way from a stop-start systems all the way to plug-in hybrids and all the way to EVs, just to show the terminologies that we look at when we talk about electrification. Obviously, no surprise, the battery gets bigger as you go from top to bottom. Okay, and then what does this mean to the customer? From a customer view, if you go up along that ladder, you start from giving customer more features and more functions, starting from shutting the engine off when it's not needed, all the way to actually potentially launch with the electric assist and drive with electrical only, with combustion engine in the backup, or do a full e-drive. So the customer does see a distinct behavior from the vehicle as you increase electrification. And somewhere, as you show on the graph there, you transition from a combustion engine-based propulsion to electrified e-drive, electric motor-based propulsion. So these are just background slides to ground this. And then when you take a look at how do you optimize this energy and how do you make sure that we minimize the energy consumption or we try to do the right thing from a customer side, here's a spectrum of where the energy pathways are coming from, taking all the way from the source of the energy to the carrier of the energy and to the user of the energy. Let me just give you a flavor of this. I don't expect you to follow this in great detail, but in the source, you have the fossil fuels, you have the biomass, and you have renewable electricity. So I think right now, currently, we are very much focused on the left side of that. Over 95% of what the automotive uses is from the fossil fuel currently. I think many speakers in the morning, including Pat Davis, mentioned that earlier. Then you can go back and say, what are my carriers? I could have the liquid fuel, and I could have the electricity, and there's many ways to generate those. As shows graph there is many pathways from the source to the carrier. And then you come back to the mobility applications. ICE on the left, all the way to the fuel cell vehicles on the right, and increasing degrees of electrification as you go from left to right. So you can take the fuels, and you can have a pathway going from a fuel to those technologies, as I showed there, or you can take electricity generated from the renewables and use it for your plug-in hybrid cars all the way to battery electric vehicles. Or you could use hydrogen generated for your fuel cell vehicles or fuel cell-based EV vehicles. So what's really clear is we must transition from an ICE-based from a fossil fuel-based technology to a renewable-based technology for us to be sustainable. As you can, and one other thought process is, currently we have a one-car-fit-all mentality that says, I want my car to do everything for me. And I think what's needed is to kind of get away from that and getting into use-dependent technology, depending on if you're a city car driver or a highway driver, or depending on your use. We need a paradigm shift to get away from one solution fits all to something very specific on it. So if I go back and look at it, I'm sorry, one car fits all that says, it's, as OEMs, we actually make certain compromises in the system design by having a one car fit all type requirement. Both from a, do we try to optimize one for the city or one for the highway, a combination of the two? And a lot of things are over-designed because we do design to the 99th percentile customer. So we need to get away from that to a more efficient, optimized for a specific city car. That gives us more choices, it gives us more leverage how we can really optimize the system and actually minimize this energy consumption concept. If this is accepted, then battery electric vehicles become a very significant part of the equation. They will become a significant part of the solution for energy minimization for certain applications. So this is actually a radical change or a change in the thought process, and I think when you look at how do we make this successful, right? What does it take to make this successful? Here's a quick graph of, if you look at what the change is on the magnitude on the y-axis and then the results on the x-axis, is it simple or is it complex change? Is it predictable or is it unpredictable? If you analyze the change that's needed in this spectrum, you'll come up with 3 buckets, transactional, transitional, and transformational. And if you look at where the EVs are, battery electric vehicles are somewhere in the transformational phase of the changes. When you have something like this, it requires a complete change of the goals, fundamental revision of the milestones, and multiple people need to work together to make this happen. This is one of the reasons of this conference being so run by IEEE, and not by one specific society, but everybody getting together running this conference. Bringing in diverse teams is really one of the necessary elements for something, awareness of something like this to make EV adoptions more successful. Okay, let's talk about who the stakeholders are. You've got the urban city planners, you have manufacturers like ourselves, energy companies, utilities, policymakers, obviously mobility service companies, and customers all coming together. I'm going to touch on one or two of these in the interest of time. I'm not going to go through the role each person plays in detail, but let me touch on one of them. Let me talk about the city first. Okay, urbanization. I mean, the population is going to increase between, I guess, from the predictions I've seen, 7 billion to 8 billion in about, by 2030, over 9 billion in 2050. The consumption from the mega cities is going to increase from an energy part of it. Dr. Weber talked about the parking issues. There's practical limitations of this. So smart urbanization is necessary for this to be successful. I mean, this is a picture of Calcutta, one of the future urban cities that's going to be, it's overcrowded today. It's going to be more crowded in the near future as well. So we end up with a smart transportation and a smart technology. When I talk about smart transportation, it's the integration between the transportation and the time. Time is telecommunications, information technology, media, entertainment, all coming together. And then you end up with smart technology with vehicles that are more connected vehicles, a smart grid. There's a lot of initiatives all need to come together for the adoption to be successful. Here's an example of a vehicle that is, that can do pretty much do everything once the person's in the vehicle. For the communication, connectivity, convenience, and safety. So this is a technology that's developed together with us as OEMs, suppliers, infrastructure providers, and urban city planners for this to be successful. So let me touch a little bit on regulation. One of the ways the governments can certainly help us is, of course, we talked about supporting from grants and other activities for us to demonstrate technology and to prove technology out. Chrysler is a recipient of grants from the Department of Energy that Pat Davis spoke of, and we are actually demonstrating, running demonstration programs around the country for plug-in technology. I don't mean to go into the regulation in specific detail, but this is just an example, a tip of the iceberg that what we face. By the way, you can do a doctorate or postdoctorate in regulations. It's that complex when you get into global regulations. Here's an example of what's going on with zero-emission vehicle standards in California. I don't want to go through every detail in the graph, but to see that before 2018 timeframe, gasoline, partial zero-emission vehicles, hybrids, plug-in hybrids, and battery electric vehicles were all receiving credits, if you will. So we have a mandate to meet certain % of our fleets have to be zero-emission vehicle-based technology. And if you look at what's going on in 2018, certain things have fallen off the list. So by regulations like this, the governments can actually drive technology to adopt technology. And it's multiple states. So there's more details behind it, but just wanted to show you an example of how a government regulation can affect technology propagation. Here's another way government can influence the technology is by the cost to the customer. You know, you talked about government credits for vehicles. That plays a major role in what happens to the technology propagation. We did a quick mathematical model. I'll just take a few minutes to go through a quick hypothetical mathematical model of a plug-in vehicle adoption here. So we talk about 4 technologies: 40-mile battery electric vehicle, extended range 40 miles vehicle, plug-in hybrid 20 miles, and battery electric vehicle 100 miles. So we'll take a small vehicle, a small A segment vehicle. Specifications are shown. We pick a certain battery size. We make an assumption that the battery cost is going to go down by 65% from 2010 to 2020. Battery has a residual value, recycle value of 25%, electricity rates assumed. So we go through certain assumptions here. And then we go back and say, OK, let's study 3 cases. One is batteries continue to go down. What happens to the customer payback in 2020? Batteries go down. Vehicle cost also goes down 3% year over year. See what happens to the customer payback period. And same one is case number 2, but the subsidies that I mentioned at $400 per kilowatt hour is taken away. So let me just click through these 3 slides. So if you look through it, the gasoline price has to be, let's take BEV 100, for example, maybe the last part of the bar graph. 2010 versus 2020, the gasoline still has to be somewhere around $5 a gallon to have a 3-year payback period with those assumptions that I made from this. Most customers are not really willing to pay for anything more than 3 years payback period. And so if you go back to the option number 2, if the vehicle costs also go down, the gasoline versus the battery electric vehicle trade-off number is going to be lower. The last part, graph number 3, is what happens if the incentives are completely gone by 2020. If you look at it, gas price has to be over $7 a gallon for a 3-year payback period. So the message is the incentives will continue to be an enabler for the propagation of this technology, and hope that continues, and that's an important part of this, even with the costs coming down for this to be effective. If you look at fleets, EVs have been used for fleets for time? Okay. Have been a very good application for fleets for a number of years, and it's been used for the last 15, 20 years for specific fleet applications. So I'm going to just skip through some of the slides here and get into the last part of the message. Okay. Let me just go back to the one more, okay. From an OEM side of it, we believe that, as I said, 2025 CO2 cannot be met without electrification. We expect electrification to be a major part of it. We're also working on combustion engine technologies, downsizing all of that. Again, the deployment of battery electric vehicles depends on a number of factors, as I mentioned, and we are getting prepared for that with the demonstration programs and other activities. We are bringing in a Fiat 500 battery electric vehicle into production this year, 100-mile battery electric vehicle that will be in production this year from Chrysler. So in conclusion, EV mobility requires a paradigm shift, and from a long-term perspective, EV could be a very dominant solution for the green economy and the CO2 problems. And the renewable energy integration is a must for this to be successful. It cannot be from the today's energy mix that we're using for EV for power generation at this 10 seconds. So with that, thank you, and I appreciate the opportunity to speak.
Thank you very much, Jay. I have to apologize ahead of time for cutting the talks a little short. The slides will be available. What I'm trying to do is save some time for questions at the end. Our next speaker will be Dr. Andrew Brown. And it's possible, Andrew has such an impressive resume that I might have to take most of the time just reading it. But I'm going to he's the Executive Director and Chief Technologist for Delphi. His career spans 40 years and includes leadership assignments at Delphi, General Motors, and Allied Signal. He's worked on a variety of engineering and manufacturing processes and systems with emphasis on energy systems, productivity improvement, and environmental efficiency. Currently, he heads Delphi's corporate innovation and technology initiatives on a global basis. He participated on the Cummins Science and Technology Council. He serves on the Deere & Company Global Technology and Innovation Advisory Council. He was a member of the Capstone Focus Group for the DOE Quadrennial Technology Review, serves as a member of the Scientific Advisory Committee of the Oak Ridge National Laboratory Energy and Environmental Sciences Director. He's been an adjunct professor at Wayne State, University of Michigan, and Tsinghua University at Beijing. He's a member of the National Academy of Engineers, chair of the National Research Council Board on Energy and Environmental Systems, and a previous member of the SAE Foundation Board of Trustees. He was previously appointed to the NRC to serve as chair of the Committee on Fuel Economy of Medium and Heavy-Duty Vehicles, which President Obama referenced in setting the new challenge on fuel economy. He is past president last year of SAE International, where he represented 125,000 members in over 100 countries. He's editor of Active Safety and Mobility Industry, Green Technologies and the Mobility Industry, and Connectivity and the Mobility Industry. And I was privileged to hear Dr. Brown speak at the IEEE Vehicle Power and Propulsion Conference last year, and I think you're in for a great talk. Andrew?
Thank you, Russ. I appreciate that introduction, and I too would agree it could be shorter. But nevertheless, let's get into our talk this morning so that we can stay on track. And I want to thank all of you for this opportunity to come before you to talk about new energy vehicles. And when I say new energy vehicles, I'm referring to HEVs and EVs. And my focus today is to highlight market and technology challenges and opportunities, and to give you some things to think about as we go forward and tackle this area of opportunity. My premise is that vehicle electrification is in fact shaping the future of the automotive power and propulsion area. I also believe that ICEs, internal combustion engines, will continue to dominate the market through 2020. And the market for hybrid vehicles and electric vehicles, as well as clean vehicle technologies, will continue to grow, motivated by the need for increased fuel economy and low emissions. You may not know it, but the fastest growth in this market will be in Asia Pacific, most notably China. The key for all of these technologies will be the value proposition that's posed to the consumer. You've heard that touched upon a bit here this morning, but that's going to be the real determinant of the success of this technology. And of course, HEV and EV technologies will not only be applicable to light-duty vehicles, but also medium-duty and heavy-duty. This whole arena, as you've heard, is motivated quite honestly by the need to reduce the CO2 greenhouse gas impacts on our environment, but at the same time, the increasing price of fuel, and sometimes not just the price of fuel, but the simple availability of precious fuel, notably oil. We continue to improve the fuel economy. We've made continued improvements around the internal combustion engines. And as we do that, that quite honestly creates a more competitive situation for the adoption of HEVs and EVs. When we speak of the issue on global emissions, the standards being established by governments around the world, where they're continuing to press for lower and lower emissions and increased fuel economy requirements, is quite consistent from nation to nation, and as a result, it affords an opportunity for electrification to play a role. In terms of expectations of this market, HEVs and EVs, whether it's this IHS Global Insight data or data from other forecasters, it strongly indicates the growth of HEVs and EVs starting to pick up here towards the end of this decade, with the emergence very strongly towards the year 2020. This chart shows all hybrids. The next chart shows plug-in hybrids specifically. But you'll notice one thing, and that is a consistency around the market that will dominate this arena. And the projections are that China will be the dominant market. Why? This chart happens to show the 12th five-year plan of China focused on HEVs and EVs. So from the very top of their government, they have identified HEVs and EVs as the primary automotive transportation mechanism in China. And as a result, they have dedicated quite a bit of their investment towards achieving a dominance in this marketplace. You might say that they're even skipping over the internal combustion engine in the sense of moving strongly to HEVs and EVs, even to the extent of fostering the increased capacity of their power generation in China to help achieve it. So there are some very specific objectives that they've put in place. Along with that, there's a range of incentives, not only at the national level, but also at the local level, depending on whether it is a HEV or a BEV, a battery electric vehicle. These incentives can amount to as much as $17,000 to $18,000, depending on the conversion rate that you use. So quite extensive commitment by that government to stimulate the growth of HEVs and EVs. I mentioned the fact that we're continuing to show improvements in the internal combustion engine, and from a market perspective, if you can in fact get improved fuel economy and lower emissions at a lower cost, why not favor that technology? And in fact, that's what's happening in the marketplace. And for this reason, you will continue to see gas as well as diesel engines play a dominant role in providing the consumer with their transportation needs. This particular chart done by the Boston Consulting Group supports that fact. As you can see on the lower row, the cost per improvement of fuel economy. So if you look forward in terms of some market studies that have been done by BCG relative to the price of oil per barrel, on the right side, $130, $180 per barrel for the different markets around the world, the projections would suggest, as I said in my opening remarks, that the internal combustion engine will continue to dominate the marketplace through the end of this decade. However, HEVs and EVs will make inroads into the market. That's not without challenges, and we come here this week to talk about some of those challenges, one of which is the battery technology. Patrick Davis earlier referred to some of these challenges, and it's not just one dimension. Not only do these batteries have to provide the energy and power that's necessary, but they have to be safe and they have to last a lifetime for the vehicle and for the consumer. There are several chemistries that are being examined. No battery chemistry meets all of the goals. Certainly lithium-ion chemistries, at least currently, provide the most promise for meeting a stated objective of somewhere in the neighborhood of $300, $400 per kilowatt hour to make it viable. If we look at the market consequences in terms of interest or willingness to adopt these technologies, it appears that in all markets around the world there's an interest, certainly in HEVs and EVs, but it appears again that in China there is a stronger interest in these particular technologies, as much as 90% showing an interest in EV technologies, followed by HEVs. So there is interest in the marketplace, but the key will be at what price? At what price to the consumer? And that's where the value proposition that is presented must be viable, and it must compete with the cost of technologies around internal combustion engines. If you look at the battery, again, in terms of what must be achieved, we're going to have to get down below $400 per kilowatt hour, more towards somewhere in the neighborhood of $300 per kilowatt hour to show economic viability for these technologies. I put this slide in as a kind of an aha to stimulate your thinking. Traditionally, we think of charging the battery by more conventional induction means. But what about charging the battery wirelessly? The idea here is to minimize the range anxiety considerations that the consumer has. This is a technology that's just now emerging that certainly has the potential to provide a very strong technological alternative to our traditional thinking around this technology. Earlier there has been some discussions relative to standards, and certainly standards will play a role, but you may not realize it that in what is expected to be the largest market in the world, most Western suppliers could not participate in the standards development activities in China until about the middle of last year. And that was because of restrictions and procedures that were established by the government and local officials. I must say, through the efforts of Western Tier 1 suppliers as well as professional societies, we've been able to convince the local governments that it's in their best interest to allow Western Tier 1 suppliers to participate. And so now there is a mechanism, there is a role that Western suppliers can play. I should also mention that as SAE president a couple of years ago, I did bring together for the first time, it turns out, IEEE, ASME, and SAE, as the first time it's ever been done, to talk about how we could collaborate on various technical matters, especially as it relates to powertrain electrification, HEVs and EVs. That was quite surprising, but we're already making progress in terms of working together on standards, working with government agencies and officials towards having some consistent standards and approaches. Just to finish off the mention of the Chinese standards, these are the various working groups that you can participate in if you so choose. This may mean some new news to many of you, but I think it's very worthwhile. I mentioned in my remarks that electrification will be applicable not only to light duty, but also medium duty and heavy duty vehicles. Most recently, NHTSA and the EPA established the first set of regulations for medium duty and heavy duty vehicles. You may not know that up until last year, we had no fuel economy regulations for trucks and buses, etc. Now we do. As a result of that, it appears that hybridization or powertrain electrification can play a role in helping those vehicles meet their standards. I show you this one draft, which came, this one chart that came out of the report that we did. When I say we, I'm referring to the National Research Council, that we did on behalf of NHTSA and the EPA. The light-colored portion of the bars, the beige, would indicate the opportunity for fuel consumption reduction on various types of vehicles and various duty cycles. Now, when I speak of fuel consumption reduction, I'm referring to gallons of fuel per 1,000 ton miles, not miles per gallon. That's the difference between medium duty and heavy duty. But there's as much as potentially a 51% reduction in fuel consumption if you look at, for instance, the bucket truck or the refuse truck on this chart as an example. Just by way of what Delphi offers, you see here some of our technology. I'm not going to go into that in depth. We have a quite extensive portfolio. And so let me conclude by simply giving you these takeaways. First of all, vehicle electrification definitely is shaping the future of automotive power and propulsion. I think that's a given. I think also that internal combustion engines will continue to dominate the market. And that's a challenge for HEVs and EVs, because that we must be comparable to. The market for HEVs and electric vehicles will continue to grow. We're seeing that and motivated by the increasing standards, whether it's fuel economy or lower emissions that are driving it. The fastest growth will be in Asia Pacific, notably China. But the value, as I stated earlier, of the technology will be dependent upon the value proposition posed to the ultimate consumer. And this technology will be applicable to not just light duty, but medium duty and heavy duty. And from a standardization perspective, we do need recommended practices for plug-in vehicles, charging equipment, and grid connectivity. We still need to do a lot of work in that area, but it's really going to take a collaborative effort between government, academia, vehicle manufacturers, and component suppliers for these technologies to be successful. So thank you very much, and I appreciate, again, this opportunity.